Hello, Mrs. Allen here. I'm here to discuss computer science at GCSE for those of you that might be considering taking it. The exam board that computer science is studied with is OCR, and the new specification is coded J277, and I will go over with you what the specification entails. So this is the specification for computer science. There are two different papers that you'll be taking, each worth 50% of your GCSE. Your first one, computer systems, is where you'll be learning about systems architecture. So this is covering the CPU, how it works, what it does, how it communicates. Memory and storage, how your computer saves data and where it saves it. Computer networks, so how one computer might communicate with another computer in the same building or in a different part of the country or even the world, how it sends the data to each other. Network security, what kind of security you should have on a network to keep data safe and how people might try and steal that data and how to stop that from happening. System software. This is the different types of software that make your computer run and how they might work. And you'll realise actually there's a lot more system software out there than you realised. And the last one for this paper is ethical, legal, cultural and environmental impacts of digital technology. This basically covers what happens to your computer, how does it affect the environment when you get rid of it? How does it affect people that might not have access to the technology that you have, how it might affect different countries, how it might affect something called the digital divide, people not even knowing how to use the technology. So we don't just look at where computers are, how they're made and how they work, but what happens when people don't have access to these kind of things. Paper 1 is 1 hour and 30 minutes and it's a non-calculator paper and it consists of multiple choice questions, short response and extended response questions. Paper 2 is on computational thinking, algorithms and programming. This is where you will look at what an algorithm is, why it's there, how a computer uses it, and create your own algorithms using flowcharts and pseudocode. You'll also look at programming fundamentals and producing robust programs, where you might be given a question with part of a program in the paper and you have to depict what's missing or what the program does at the end. Boolean logic covers true and false to do with binary, so electronic switches that are on and off and what they might be doing in the computer and how that might affect the outcome of what the computer is doing, and also programming languages and how they work. Paper 2 is also 1 hour and 30 minutes and it is a non-calculator paper and it has section A and section B. Section B assesses students' abilities to write or refine algorithms and they need to be answered using pseudocode or flowcharts or programming content. So, why study computer science? Well, do you like logic? Do you like thinking logically about things? How to take a problem, break it down into steps and solve that problem? Do you like creating things? Do you like the internet? How it works? Do you like programming? Making a brand new program, making it work? Asking your friends to answer the questions on the program? Do you like a little bit of maths? Do you like technology? Is technology something you really like? If you answered yes, and you do like some of those things, you could end up in a really big career in computer science. For example, with robotics, you could end up making the next best robot to help clean the house, load heavy equipment for the army. You could work in app design. You could be designing apps for your mobile phones and your tablets that people will use on a day-to-day basis. You could work in games. Not only do games need to be tested, but they also need to be programmed. People can become games testers as well as programming them at the same time, so you get the best of both worlds. You could end up programming in cybersecurity, creating programs and checking the World Wide Web on a daily basis to make sure that there are no attacks on the UK to try and steal data, keeping our country safe. You could work with electronics, building new electronics to be used, such as new CPU chips in computers. Technology is ever changing, ever increasing. Our technology is getting faster, and we need the electronics behind those. You could be the one making those. Or you could be working in a future career. A future career is something that doesn't even exist yet, but where computers are becoming a part of our day-to-day lives more and more, there are inevitably going to be jobs in the future that don't exist right now, but we will need at some point. In computer science, you will gain experience with programming. This programming will help you to make new programs, and in the future you could make new softwares. It will help you to discover how the computers work and how they read these programs, and also how they use programs in order to solve problems, such as sorting data or searching for data on the computer, something that we do every day. Drones have not been around for a very long time. However, they're getting better and better with the technology that they use. They're used for filming rescue and more. In future, they're going to be used for deliveries, such as Amazon packages to your house. These drones need to be programmed though. You could end up working with drones programming them. We know from Key Stage 3, Year 7s, 8 and 9, that the CPU is the brain of the computer. It's the thing that deals with all the instructions and makes it work for us. Did you know that a foundation called ARM creates CPU chips? They're regularly referred to as ARM CPU chips. They're found in mobile phones as well as computers. CPU chips are forever changing. They're always increasing in speed and capability of what they can do in a computer. Take Intel, for example. A few years ago, they started with the Core i3 and the i5. Then they brought out the Core i7 and the Core i9 chips. They're forever changing, and we need people like you to create the next best CPU chip to keep up with the daily tasks that we ask them to do. I said before that with computer science you could end up working in robotics. Robots are being used all around the world every single day, including in car assembly. In plants all across the UK, for example, robots are being used to put the cars together. Parts of the car are very heavy for humans, and this is where a robot comes in which can easily lift parts up, put them together and solder them for us, thus creating the vehicles that we use on a daily basis. There are also robots that clean for us, such as the Roomba robot or the RoboVac. Small little hoovers that are robots that wander around the house picking up crumbs for us to save us time hoovering every day. In order to make these robots, you need to have a good understanding of how the computer works, because not only would you need to build the robots, but you would also need to program it after to tell it what it needs to do. There are many different jobs you can do in the future with computer science. If you have any questions about the course, feel free to email me at kallen@tenburyhigh.co.uk.